Welcome to the lesson on basic concepts of geometric dimensioning and tolerancing. Upon completion of this lesson, learners will have acquired a comprehensive understanding of geometric dimensioning and tolerancing. They will be able to construct and interpret technical drawings of simple parts using GD&T principles, demonstrating practical application of the concept. Learners will be equipped to identify and examine various uses of GD&T in manufacturing contexts. They will be able to explain why GD&T is used and its benefits in engineering and manufacturing. GD&T is a system for defining and communicating engineering tolerances through technical drawings. It uses symbols to describe nominal geometry and its allowable variation. It conveys the degree of accuracy and precision needed on each controlled feature of the part to the manufacturing staff. So now that we understand a little bit about GD&T, let's talk about how and why it is so commonly used in the manufacturing industry. There are many terms and symbols involved in GD&T. In order to be able to read and understand technical drawings using GD&T, let's visit an example. Here you see a block that has a hole in it for a pin. If you wanted to create this block, you would need to know some information about it, such as its length, width, and height of the block, as well as the features of the hole. Technical drawings, such as blueprints, give you this information for products to be produced. When creating the object in a technical drawing, three datum are identified. A datum is a theoretical plane, point, or axis used to measure a dimension on the part. In a technical drawing, datum are marked and used as a reference to understand the position of the part. Each datum is usually named A, B, and C. The image on the right shows these three datums around the block. This figure displays how the block with the hole from the previous slide would be seen in a technical drawing, from the top with the GD&T information. As you can see, datum B and C are marked on the drawing. The drawing also shows the basic dimensions of the block. Baseline dimensions are those that provide basic measurements of a part. For example, the length of the part is set at 4 inches and the width at 1.5 inches. The technical drawing also shows that the diameter of the hole is 1 inch. The group of boxes on the right of the drawing is called a feature control frame. The feature control frame describes the feature that is marked in its geometric characteristic symbol, tolerance value, modifiers, and datum references. In this case, the feature control frame provides information about the hole in the block. The next slide explains the feature control frame and modifier in detail. Let us take a closer look at the feature control frame. The image you see here breaks down each section of the feature control frame. The first box on the left specifies the geometry control tool. In this case, the symbol refers to the position of the feature. It means that the hole in the block is aligned with the midpoint of the length and the midpoint of the width of the block. In other words, it's in the very center of the block. The next box of the feature control frame specifies the tolerance zone. The first symbol denotes a diameter. The second number denotes the allowable tolerance. In this case, it is plus 0.003 inch. This means that the hole can have a diameter between 0.997 inch and 1.003 inch and still meet engineering specifications. The last symbol in the box specifies the tolerance zone size modifier. Modifiers communicate additional information about the feature of the part. In this case, the modifier refers to the maximum material condition, which we will discuss later in this module. The last boxes on the right tell you which datum are used as references for this object. Now, let's take a look at the technical drawing section of the front view of the block and analyze it. Datum A is marked on the drawing that matches the location of the datum. So we were looking at the block from above before, but now we are looking at it from the side, so we use datum A as a reference. The drawing shows that the height of the part is 3.5 inches. The dotted black lines indicate the location of the hole. The lines are dotted as opposed to solid because the hole is an internal feature. The dashed red line indicates the center line of the block. The corresponding feature control frame describes this center axis as perpendicular with a tolerance of 0.010 inch. This means that the axis line can bend 0.010 inch in either direction and still meet engineering specifications. GD&T is used in many stages of the product design and manufacturing process. Below are some instances where GD&T is appropriate to be used. When studying features that are critical to function or interchangeability for functional gauging techniques, to ensure datum references are clear and consistent between manufacturing and measurement, and to ensure tolerances are clearly marked or are different than standard tolerances. So why should companies use GD&T? This system offers several key advantages in manufacturing. It helps save money by optimizing production processes and reducing errors. GD&T provides maximum manufacturability through its use of standard tolerances and clear design features, allowing for more efficient production. It is also well suited to modern manufacturing, with the ability to adapt to and assist computerized techniques in both design and production phases. Perhaps most importantly, GD&T simplifies drawing interpretation, minimizing confusion and guesswork during the manufacturing and inspection processes. This leads to fewer mistakes, less rework, and ultimately a more streamlined and cost-effective production cycle. GD&T provides an international language for reading technical drawings, which is a significant improvement over the traditional methods. Previously, technical drawings included numerous notes that have now been replaced by GD&T symbols. GD&T also offers greater design clarity, improved fit, better inspection methods, and more realistic part tolerances in the technical drawings of parts. Lastly, GD&T is also able to show how features relate to one another, therefore improving quality when manufactured. Overall, GD&T provides companies with a quick, simple, and standardized way to communicate highly technical and specific product design information. In summary, geometric dimensioning and tolerancing is an important system in manufacturing that enables technicians to interpret physical characteristics from geometric symbols on technical drawings. It utilizes datums, which are theoretical references for measuring part dimensions, and feature control frames that describe marked features using symbols, tolerances, and references. GD&T is particularly valuable for critical features, as it improves manufacturing processes and simplifies drawing interpretation. It provides a universal language for technical communication, which improves overall quality and clarifies relationships between different parts in assembly. By standardizing these aspects of design and production, GD&T significantly streamlines the manufacturing process and reduces potential errors or misunderstandings. Thank you.